Now let's talk about particle forces, how we can use forces to control the behavior of our simulation with using the forces. And right now, here as you can see, we are using the pop force node. And in here, I have default out all of the settings. And at the very first, you know that we have the axis and on which axis we want to add the force. And in here, we also has a node called pop wind. Let's add a pop wind node. And if I were to enable the parameter, and here as you can see, we have most of the parameters, they are look the same onto the pop force as well as onto the pop wind. In here we have this wind velocity, we have the same axis, the x, y and z, and in here we have this additional parameter, we have the wind speed, and we also have the air resistance. And same thing onto the pop force, we have the force, we have the axis, and down here we have the noise, and we have all of the noise option onto the pop wind as well. Let's see what is the difference between the pop force and the pop wind node is. If I were to enable my pop force, let's say I'm going to add an F force onto the X, and let's add this into 1 by using this parameter, and now we are adding the force onto the X. And here as you can see, these particles are going to be accelerated over time. And here as you can clearly see that they are starting slow, and over time they are going to be accelerated. So the pop force is a force of acceleration. So all of these parameter is going to be accelerated over time. And in here, by using the pop wind node, if I were to remove the pop force node, let's add a pop wind in here. And same thing, I'm going to add a wind velocity onto the X. Let's change this to 1 and hit play. And here as you can see, we have this wind velocity X uniform. That is a uniform force, pop wind. It's not going to be accelerated over time, but it's going to be a uniform velocity onto the one entire of this simulation duration. And here as you can see, and if I were to just remove this, and let's add a pop force node in between, and let's hit play. And here as you can see, they are starting slow, and as the simulation progresses, they are going to be accelerated over time. We can use this pop force node to, for example, create a gravity force, because as you know that gravity is a force of acceleration. So we mainly use this pop force to add the gravity effect. And onto the X, I'm going to just zero this out. And to add the gravity, we know that the gravity value of our Earth is 9.8, because we are working within this 3D scene and we have all of these axes, and the gravity should move these particles down, which means we need to add a force value of minus. So we need to add a minus 9.8. And if I were to add just 9.8, as you know, it will be a positive value and our points will move up. And here you can see our particle simulation is moving upward. And to create the gravity, we just need to add a minus sign in here, which means that we are creating a gravity, and gravity is pushing these particles down. Let's hit play. And here you can see we have these particles moving down with the gravity value. And in here we also have a gravity force. If I add a gravity, and here you can see we have a gravity force node. If I add this, and here you can see this gravity force node looks different than this pop force node, and that is because this gravity force node is designed to work with all of the solver. And as you know, we have inside of the dynamics, we have all of the solver. We have this particle solver, and we also have our smoke solver. If I add this, and we also have our RBD solver, and let me find here, I have the RBD solver. So we have all of these different types of solver for different types of simulation, and this gravity force is designed to work with all of the forces or all of the solvers, which means I need to connect this after the pop solver. So whenever you have solver, first you need to create your solver, and down here you can just add the gravity and it will work. And I'm going to just remove the pop force node in here, and here as you can see I still have the gravity. And same thing, you can also connect this in here into the pop object and it will work fine as well. And here as you can see, you can add the gravity like so, or you can use the pop force node and add an -9.81 to connect this in here, and that way I can create my gravity. I'm going to just remove this gravity force. I'm just going to use this pop force node to create my gravity. And in here now we have this pop wind, and as you know that pop wind is a uniform force, so let's add a pop wind in here. And in here I can just add the amplitude to add a noisy wind. Let's increase some of the amplitude value so that we have some noise. And here as you can see our gravity is pushing particles down and we have some of the noised up velocity because there is a wind in our this 3D scene with this pop wind node. And in here I can adjust the wind speed. Let's increase the wind speed and hit play, and here as you can see our wind speed has been increased. Let me keep increasing this, and here I can clearly see the effect of the wind speed. And down here we have the air resistance. This air resistance is a force of drag, which means it will drag down this wind speed. It will, right now it's very hard to see. Let me increase this air resistance to a higher value, and I still cannot see the effect of it much, but basically it will add a drag force in here. Maybe if I were to just remove the pop force node and in here create a pop wind and hit play, and right now it is a very chaotic animation. Let me change this to value of 1, and I think I need to lower down the amplitude to a lower value as well, and let's hit play. And this air resistance is basically dragging down all of our forces back. We also have the drag force in here present. If you create a pop, if you type pop and add a pop drag, and here as you can see we have the pop drag force, and we have the pop drag simple, and we also have the pop drag spin. And this pop drag spin, it will drag down the spinning motion of the particles. And right now we are not adding spin in our particles, we are just using the noise to add a noise up wind velocity. I'm going to just zero out the air resistance, and maybe let's increase the amplitude value. And I think we need the air resistance because it's a multiplier to have an a effect. And after that I'm going to add a pop drag node, and let's connect this in between. I'm going to just remove this pop drag spin. Let's go into the pop drag, and here as you can see we have the same parameter. We have the air resistance and we also have the wind velocity, but in here we do not have the noise in here. Onto the pop wind, here as you can see we have an additional noise. In here we do not have the additional noise, and in here I can keep layer down the air resistance. It will continue to add a drag force in between, and here as you can see our particles are now sticking together because there is a drag force that is dragging these particles down. And in here if I were to remove this pop drag, I'm going to just shake this node off and hit play, and here as you can see we have these particles going every way, and right now all of the particles are sparse, and here as you can see they are very sparse. There is a much more separation going on in our particles. And if I were to add a pop drag, and this pop drag will going to be drag down all of these forces, and that way these particles will stick together. And here you can clearly see that now we are getting some of the clumps, and that is the pop drag force. It will drag down all of your forces. So I'm going to just remove both of them, pop wind and pop drag, and let me hit rewind and onto the pop source. In here we forgot to talk about this birth tab, and in here we have the impulse activation and the impulse count. Right now the impulse activation is on and the count is set to 0. And down here we have the constant activation and we have the constant birth rate. And right now we are using the birth rate of 5000. This constant activation and this birth rate mean that how many particles our this system should emit in the course of 1 second. And as you know that right now we are using the 24 fps, and I can confirm if I enable my this global animation option. Let's enable them, and here as you can see we have the animation option, and at the very first we have the fps, and in here as you can see we are using the 24 fps, which means at the frame of 24 we have reached a 1 second. So it means that at the frame of 24 we should see 5000 points. And if I were to middle mouse button, and here as you can see we have 5000 points. So constant activation is the amount of particles emission over the course of 1 second. I can increase this birth amount and we will get that many particles over the duration of 1 second. And on the second, which will be the 48, we will get this number double, which means that we have twice amount of these particles, because right now we are at the 48 frame, which is happen to be our 2 seconds. And that's the constant birth rate. And we have the impulse activation. And if I were to zero out the constant activation, if I were to zero this out, it means that we are not using the constant birth rate. So no matter what value you should put in here, this parameter will have no effect because we are not using it. And we can control this by this activation. And in here onto the impulse activation, the activation is enabled, but there is an impulse count and it is set to 0. It means that how many particles you want to emit every frame. And in here I can say I want to add 100 particle every frame. And if here as you can see right now we are at the very first frame, and if I were to middle mouse button, and here as you can see I have 100 point. And same thing if I go on to my second frame, now I am at the frame number second frame, and now I should see 200 point. And if I were to middle mouse button, and here as you can see we have 200 points, and I can keep playing this. And if I were to middle mouse button, and here as you can see our this point count has been reached to 1600. So the impulse count is control how many particles you want to create every frame. And I can control this. If I were to go into the impulse activation, let's zero this out, which means that we're not using this value. I'm going to enable the constant activation. Let's change this to 1 and hit play. And I think I'm going to lower down the number of particles. And down here, maybe first let's create a force in here. I'm going to just add a pop force. And as you know that not pop access force, but the pop force node. Pop force, I'm going to just add some noise in here. I'm going to just introduce some noise by adjusting the amplitude value and hit play. Let's go back onto our this pop source node, and in here we have the life expectancy, and right now we are using the 100. This life expectancy is in seconds, and if you hover over to the parameter, and here as you can see we have the information how long the particle will live in seconds. So right now our particle will live 100 seconds. I'm going to just lower this value down to 1, which means that now our particle will only live for 1 second, which means at the course of 24 frame. Let's go back and hit play, and here as you can see at the course of 1 second all of our particles are going to be removed from our simulation. And same thing, I can increase the life expectancy if I want to live these particles, make these particles live long. I just need to increase the life expectancy, and now we should have a longer lifespan of these particles. I'm going to just change this to 1, and in here we have the variance, which means I can add a random variance in our these particles, and right now here you can see all of our particles are being died off at the same time uniformly. And in here I can just introduce some variance by adding a life variance in here, and now we should see the particles, and in here we have the variance of plus and minus 1 second, 1.3 second, and in that way I can randomly make these particles disappear from our simulation. And onto the next tab we have the attributes, and in here we are inheriting the velocity. Right now it says inherit velocity and use inherited velocity, and it means that if I were to remove this power force, now I don't need the power force, and in here we are saying that use the inherited velocity. It means that please use the velocity attribute that is present in our source, and right now we do not have a velocity present in here. If I were to middle mouse button, and here you can see we do not have a v. V is used for creating the velocity, and currently we do not have that. And what we can do, we can create a v in our this SOP level, and this v will going to be inherited by our these particles or this particle pop source, and this pop source, this particle simulation will use this velocity to make this particle move. And in here at the sphere I can create my v by adding a point velocity node. So if you type point, and in here we have this node called point velocity, let's add this, and we need to just connect this. And what this point velocity node will do, it will add a attribute v if I were to middle mouse button, and here you can see we have a v and it is a vector, which means we are adding the velocity, and we are initializing this from compute from deformation, which means that it is calculating the velocity if we have the animation on our geometry. And right now here you can see our sphere is static, it's not moving, which means our this velocity attribute should be empty, it should be 0. And I can confirm if I go into the geometry spreadsheet and into the v, and here you can see its value is 0 because our this geometry is not moving. What I can do, I can go into the point velocity node in here, and onto the initialization I can just set this to value. Let's add this, and in here I can use these value. We have the x, y and z to initialize this our velocity. I can say onto the x I'm going to just change this to 1, and now our this initial velocity has been initialized. And if I were to go into the geometry spreadsheet, and here as you can see we have the velocity onto the x-axis, which means if I go into the this back onto this network, and we should see the movement. And here as you can see these particles are moving because they are inheriting the velocity from SOP, from this point velocity node, which means I can go into the noise tab. In here I can add the noise in there. You can actually visualize your velocity vector as well, and if you want to visualize your velocities, just hover over to that node and press on this node info button, and that way we have this window pair. And in here just click on this v button, and that will add a visualizer. And here you can see we have these yellow lines, and these are the velocity vectors. And right now this noise is noising up this velocity, and if I were to disable the noise, and here as you can see we do not have a noise in our velocity. Let's enable this, and right now we have an animated noise option enabled, which means if I were to play, and here as you can see we have some animation onto our noise. And to hide the visualization, let's click on this I button and click on this V again, and that will hide the visualization. And now if I go into this top net, and I think I need to go to the very first frame, and let's hit play again, and here as you can see we have this random force, and they are using the inherited velocity, which means we are using this velocity that is coming from SOPs, which means I can enable the scale, and this scale is an amplitude, And if I were to increase the swirl size, that will create a high frequency noise. And now if I were to hit play, and here as you can see, we have a bigger movement in our particles. And same thing, if I were to lower down my swirl size, we should see the smaller breakups. And in here as you can see, we have particles going in every direction because of this smaller high frequency noise. And in here onto the top net, it is always a good idea to add a pop drag, because this pop drag will going to be drag down our force. Let's add this in here, and let's start with the default value of air resistance 1, so that we have some sort of resistance in the air. And let's hit play again, and now here as you can see, our particles are now sticking together. Let's go into the point velocity node in here, and that is the swirl size. I can adjust the pulse duration to create an animation faster. If you want to create the animation faster, you just need to lower down the duration value. If I were to lower this down to 0.1, we should have a faster animation. And I think it might be easier if I were to just visualize my velocity vectors and hit play. And here as you can see, we have a very fast animation. And if I were to increase the pulse duration, and here as you can see, we have a very slow this movement of our noise, and that is the animation. And let's go into the top net, and I think I need to just disable the velocity vectors. Let's go into the top net, and in here onto the pop source, I can control the inherent velocity scale. Right now we are using all of the velocity, inherent velocity scale to 1. I can increase the multiplier if I were to increase this value, and here as you can see, we have just increased the amplitude of our velocity. And same thing, I can just lower down my inherent velocity scale, and now here as you can see, we have a slower movement. And same thing in here, we have some other option. We can add the velocity to the inherited velocity. If I enable this, which means we are importing the velocity from SOPs, we are inheriting, and we can also add some other velocity by using this pop source, which means I can add additional velocity onto the X. Let's add a 1 in here, and maybe let's increase this value to 5 and hit play. And here as you can see, we are importing from SOP, and we are also adding this to the inherited velocity in here. And in here we have the option to variance, or I can just change this to set initial velocity, which means that we are completely ignoring the velocities that are coming from SOPs, and we are just initializing our velocity from our pop source node. If I were to zero this down, and maybe let's zero out the variance, no variance has been added. And here as you can see, even though we have the velocity, we have the point velocity node, and we have the V, we are not importing inside of top. And in here, I can just say, please add the velocity, initial velocity 1, and here as you can see, we have some. I can introduce some variance if I want, and we have some variance velocity, and now particles are moving in every direction. Let's stop this lecture now, and in the next lesson, let's explore all of these parameters and some other forces in the next lesson.